Hello and welcome. So in this session, we are going to talk about key value RDD. So in last session, we looked at RDD as a beginner, and we saw an RDD where every element in the RDD was a single element. Every row in the RDD was a single element. A key value RDD, also known as paired RDD, contains two things at every row level, one key and one value. And these keys and values can be objects as well, right? It's commonly used to perform aggregations where you want to, let's say, group by some key, combine all the values corresponding to a key together, and let's say sum them up or perform any operation on all those values, right? This RDD provides some special operations, as I said, like reduce by key, where corresponding to one key, you can reduce all the values together by providing some function. Group by key, where you get all the values together for one key. Sort by key, where you can sort the RDD based on the key. You can join two different RDDs together based on a common key. One thing to note here is that in a key value RDD, it's not really like a hash map. Hash map is a data structure where your key is unique. You can have only one entry with one key. Whereas in case of key value RDD, you can have multiple rows that contain the same key. And that's the whole purpose, right? Let's say you have some data set where there are multiple rows with the same key and you want to combine them together. So once you perform that operation of combining or reducing them together, that is the time when you have one row per key, right? But before that, in your key value RDD, you can have multiple rows where you have the same key. We'll understand it more with the help of an example. Uh, so let's look at this problem statement. Let's say we have some data where you have the scores for every subject for different students, right? So your data set will contain the roll number of the student, the subject, and the score that this guy has scored in that subject. So obviously, for the same subject, you will have multiple entries, right? Where every student will have some score corresponding to that subject. And the use case is that we want to compute the average score in each subject. Let's say in subject one, there are 20 students and they have scored different scores. And now you want to figure out what would be the average score per student in that subject, right? So that's our problem statement. The logic that we are going to use here is think of it, think of this problem without Spark for a moment. Let's say you have n number of data entries where every entry has a subject and a score, right? In general, the way you would solve this problem is you would aggregate all the scores for a subject. You will count how many students were there in the data set, and you will divide the total score by the total number of students, right? So that's a very simple problem. Obviously, this problem we have taken for the sake of learning. When we are talking about big data, it's not that simple problem, right? You want to distribute this processing across machines. And that is why we are talking about Spark. And that is why we are talking about RDD, which is a distributed data set. So the logic that we are going to use here is we are going to use the data from file into a Spark RDD. At this moment, this RDD is not going to be a key value RDD. It's going to just contain every row. And then we are going to transform this RDD into a paired RDD where key is going to be the subject and your value is going to be the score. Okay. Once you transform this RDD into a paired RDD with key as the subject and value as the score, then you are going to transform this RDD into another RDD where your key is the subject and value will again be an object, a tuple, where it will have the score and a value of 1. The reason we are going to do this is so that when we add these two elements of the tuple separately. So for example, if you add all the scores, you get the total score. And if you add all the ones in the value part, then you'll get the total number of students for which you have those that total score, right? So that you should be able to divide that total score by the total number of students. When we look at the code you will understand it better. So for now, let's just say that we are going to convert this RDD into another RDD where you have key as the subject and your value has two elements. One is the score and another is a constant 1. Okay. Now, as I said, we are gonna aggregate all the scores together and we are gonna aggregate all the ones together. So you get two numbers for each subject. One is the total score and one is the total count of students for that subject. And finally, you divide that total score by the total number of students and you get the average score per student for each subject. All right, so let's jump to the code. Let's first look at, let's first look at the format of the data. So I have this scores.csv. The format, as I said in the PPT, you have a roll number, you have a subject, and then you have the marks scored by that student in this subject, right? So similarly, just like you see math here, you'll have another other subjects as well here, like Hindi, English, science, and all those subjects. Now let's look at the code. Okay. So let's try to understand what's happening here. Let me actually increase the font size because it might not be very easy to read. How do I increase the font size? Yeah, should be better. So let's look at the core logic first, and then we'll talk about the other things. So the core logic starts from this point where we are creating a Spark context. We are saying that we are going to run it in local mode, and this is the name of the application, lesson 4 project. So we create the Spark context, and the first thing that we do is we create the base RDD. We call it row RDD from this file that we just looked at. Okay. sc.text file, this function will actually convert this file into an RDD, which we are calling row RDD. The second function, what we are going to do here is we are going to apply a map function on this RDD, and we are supplying function extract key value to this map. Let's look at extract key value. This function is taking a string as an argument, which means when you are applying it as part of this map, every row in this row RDD will be passed to this function. Okay, and whatever is the outcome of this function will become a row in key value RDD. Okay, so what we are doing in extract key value function is we are splitting every row on comma. Okay, and we know that our subject is at index 1 and score is at index 2. So val subject is at fields 1, val score is at fields 2, and we are converting score to an integer. So subject and score we have extracted from that row, and we are returning subject and score as a tuple. So in Scala, when you do this, it becomes a tuple, and you are returning this tuple from the extract key value function. So if you look at it, when you supply this function extract key value to the map, which is applied on row RDD, what Spark is going to do is it will basically run this function on every row in this RDD, right? Which means every row in this RDD will get passed to this function and will return subject and score, right? And when it returns this, it becomes a new RDD which contains subject and score as elements in every row. And hence, this RDD is a key value RDD because it contains two things now. One is subject, which is your key, and one is score, which is your value, right? So once you have this RDD, then this is the line where most of the logic of this use case is being performed. Let's look at it part by part. Let's first look at the first part, which is map values. So map values is a function, okay, which when applied to a key value RDD does some operation only on the values part of that RDD, okay? And that's why it's called map values. It's not going to touch the key. It's just going to work on the values part. And in this function, what we are doing is we are converting every value into a tuple again, x comma 1, right? Which means, let me actually write some comments here. So what's happening here is, let's say your input row is 1, math, 50. Okay. From this, your RDD became math, 50. Right. This was the key and value of your RDD. Okay. After you apply this math values, okay, after you apply this math values, it becomes, because it's not going to touch the key, so key remains math and your value becomes 50, 1. Right. So now after applying math values, what you're doing is this is your value and you're converting every value to a tuple of value, 1. Right. So your math 50 becomes math 50, 1. Okay. Now this becomes a new RDD. Okay. This becomes a new RDD because you have applied a transformation on this RDD. So this becomes a new RDD in which every row is in this form, subject, and then your value is score, 1. Then you are applying the transformation reduce by key. Okay. Reduce by key is a special transformation which is available only on key value RDDs. Okay. Obviously, if you don't have a key value RDD, you cannot use this function because this function specifically works on paired RDDs. This is something to be understood very, very clearly. What we are doing here is we are doing x dot underscore 1 plus y dot underscore 1, which means, let's say if you had two such key value pairs, okay, let's say 60, 1. Okay. Now what happens is, what you're doing here is x dot underscore 1 plus y dot underscore 1, which means this is your x, this 50, 1 is your x, this 60, 1 is your y. Okay. So x dot underscore 1 is 50 and y dot underscore 1 is 60. Right. Which means you are summing up the scores here, x dot underscore 1 plus y dot underscore 1. Similarly, when you talk about x dot underscore 2 and y dot underscore 2, x dot underscore is this 1 and y dot underscore 2 is this 1. So when you sum these up, it becomes 2. And what happens is, this reduce by key operation is being applied in a progressive way, which means once you sum up these two rows, then this summation gets aggregated to the third row, and then that summation gets aggregated to the fourth row, and so on. So which means at every stage, this part is going to contain the sum of scores, and this part is going to contain the sum of these ones, which means we are counting the number of students. Let me try to explain it once again. So in reduce by key, you are supplying x and y. X and y is basically value part of two rows, the first row and the second row. Okay, so the value part of two rows, 50, 1 and 60, 1. So 50, 1 is x, 60, 1 is y, right? And what you are doing here is x dot underscore 1 plus y dot underscore 1, which means you are adding 50 to 60. And similarly, x dot underscore 2 plus y dot underscore 2, you are adding 1 to 1, which means after this first operation, it becomes math, 110, 2. Right? And now this summation will then get aggregated to the third row. So let's say there was a third row as well. Let's say 70, 1. Okay, so in first stage, it became math 110, 2. And then it becomes math 110 plus 70, 180, 3, and so on. So it will keep adding each row where the key is same. Okay, please note that the key has to be same when it is doing this aggregation. So where the key is same, it will keep aggregating the scores and it will keep aggregating the counts, right? Which means after this step, after this whole step, what you get in totals RDD is an RDD where your key is the subject and your value is the total scores in that subject and total number of students in that subject. Does that make sense? I hope so. And once you have that, now your total RDD, as I said, is something which contains subject and total score So let me write it down. So your total RDD totals RDD is actually what contains subject as the key and total score, comma, total count as the value, right? And what we are doing in this step is we are again applying a function map values because we want to keep the key same for every subject. We want to compute the average, and average can be computed from these two numbers, right? Now this x is nothing but this tuple, right? This x is nothing but this tuple which contains score and count. So what you are doing is x dot underscore 1, which is total score, divided by x dot underscore 2, which is total count. So your average scores RDD is now what? You have a subject because you didn't change the key in last step, and you have a value which is average score, right? And then at this stage, you apply an action which is collect. Collect, what it does is it basically returns the results from all the partitions, all the nodes to the driver, which means this result, right? Result of this RDD, all the data present in this RDD is returned back to the driver. And then what driver does is it iterates over this average scores RDD and it prints every row. That's it. So let's delete these comments and let's try to run this program. So I already have build script. Let me run the compilation. So once you compile it, it will convert it into a jar, and then we can use Spark submit command to run this jar as a Spark job. All right. So we've compiled it. Now let's use Spark submit, and the jar would be somewhere here. Its name is lesson 4. All right. So when you run this, it's gonna launch it as a Spark job on a local cluster. We have run it in the local mode, and if you see, it has emitted out average score for each and every subject. Right. A few things to note here. Let me go back to the code. A few things to note here. When you're applying all these transformations like map values, these are happening, on all the partitions in parallel, right? So for example, if your data is divided into, let's say, 10 partitions, and those partitions are, let's say, being processed on different nodes, every partition on every node will run this function, okay, separately on its own part of the data. But when you do reduce by key, this is the time when something called shuffle happens. Because think about it, you might have one partition on one node which contains some rows corresponding to a subject math. But corresponding to subject math, you might have some other rows present in some other partition on some other node, right? Which means you cannot get the total score for subject math and total count of students for subject math if you completely do it, distributed. So what happens at this stage is your data gets shuffled. So what Spark does is, because it knows that you are reducing by key, it will try to bring all the data corresponding to the same key together on one node. Okay. So all the data that belongs to, let's say, subject math has to arrive at same node, right? Before you can actually get the total score and total count. So that shuffle happens at this stage. Obviously, this stage is executed only when you call an action which is collect. But as part of that stage, the data will get shuffled. We'll talk about shuffle operation in detail in another video. But at this stage, I just wanted to introduce you to the concept of shuffling, right? Because your same key might be present on different nodes as part of different partitions. In order to compute the total score and total count corresponding to that key, you need to bring all the data together on one node. Okay. There are a lot of optimization techniques to avoid a lot of data shuffling. We'll talk about them in another video. But concept of shuffling is something which gets used when you do something like this. All right, that's mostly it about key value RDDs. If you have any questions, please let me know through the comments. Thank you very much.